I am so excited to be joined by Julie Wallace, who recently published a paper on the effects of marine heat waves on the behaviors of Atlantic puffins in the Gulf of Maine. Julie is a geoscientist with a PhD in environmental science from the University of Waterloo and has a postdoctoral fellowship in geospatial science from McMaster University. She is an ardent viewer of the Explore.org website and used data from the Explore.org cameras to inform her paper. So thank you so much for joining us today, Julie.
Thank you. It's such a pleasure to be here. I am going to share my screen with you now.
Yay!
So that you can see.
Yes. So I'm excited for your presentation. You're going to be presenting on your findings in the paper, correct?
Yes, I am. I'm just trying to bring up my paper here, and it's not being very cooperative, but I'll have it here in a minute. And then we can get started. So I am just not seeing my paper showing up here.
Yeah, so we've got a little bit of time here. Just as long as you're hitting the share and you have that in a separate tab, should be all good.
Yeah. Okay. Okay. You got that now? Can you see that now? Oh. Okay. Let me do that again.
And if you need, I also have a copy of it here, so I can just either drop the link to the Dropbox file in the chat, or we can.
Okay. I think we've got it. I think we've got it. Okay. So thank you all after that little technical glitch. Thank you all for coming to this talk. And my name is Julie Wallace. For those of you who watch the Puffin cams, you may know me as Puffin 123 or P123. And this paper actually came out of some data that I collected from the webcam. So it's titled Atlantic Puffins. The presentation is titled Atlantic Puffins, Puffin Prey, and Marine Heat Waves, and that's what we're going to talk about today. So first up, I'd like to dedicate this body of work to Anne Aspas. Many of us know her. She's a puffin viewer extraordinaire. Unfortunately, she passed away a few years ago, lovingly known as Amma, and she actually contributed a lot to the site. So thank you, Amma, for your love of puffins and for your perseverance and courage in enhancing the viewer experience. So what is this body of work? This body of work actually culminated in this publication that was published last fall. The title is Behavioral Response of Atlantic Puffins to Marine Heat Waves in the Gulf of Maine, and it's a webcam study. And so webcam study because the borrow is actually equipped with a webcam thanks to Explore. And so we have 24-hour viewing of these cams. Now, what's the objective of all of this? Now, we know that rising sea surface temperatures and marine heat waves impact food availability. So impact the quality and the quantity. And this is a food that pufflings need to eat to thrive and to grow during the breeding season. So how do these things and the food availability issues, how do these affect adult puffins and puffin chicks? So our study looks at a single burrow on Seal Island in the Gulf of Maine. As I said, it's equipped with a webcam that's fixed. We collected data for 5 years from 2017 to 2020 and 2022. We didn't collect for 2021 because there were issues with the webcam in that particular year. So over these years, we've had one male and two females, not at the same time, at different times. So from 2017 to 2018, we had one female, we called her Billy. And from 2019 onwards to today, the other female, we call her Millie. So the data we collected, for each day, we collected the number of feedings and which parent brought that feeding. We collected, where possible, the species of prey that was brought in. And we also collected the number of hours that each parent spent in the burrow. So that's their burrow attendance every day for each parent. And we used sea surface temperature data from NOAA. And there's a link in the sources at the end of the presentation that links to the website for that. Now, a little bit of background. The Gulf of Maine has historically been a subarctic environment. So cold waters come down from the Labrador Sea. So it's relatively fresh cold water comes down. It comes down along the eastern coast of Canada, United States, and flows into the Gulf of Maine. And the red arrow shows you where the Gulf of Maine is. So traditionally, it's been cold water that comes in. But recently, there has been a rapid rise in sea surface temperatures. And when that happens, the marine species that are used to cool water will seek cooler environments. So they migrate north, or in the case of the Gulf of Maine, northeast, or they'll go deeper where the water is cooler. Now, this is a problem for puffins because they need to forage close to their burrows. So they typically forage within 20 kilometers. And for diving, they typically dive less than 20 meters. So typically around 10 meters or so that they dive. So they're not very deep divers, and they're not very efficient long distance flyers too. So they actually need to be able to forage close to their burrows, and that's the ideal situation for them. Now, when we talk about the warming of the Gulf of Maine, what does that look like? This is a graph from the Gulf of Maine Research Institute. On the x-axis, at the bottom, horizontal axis, these are the months. So it goes from January on the left-hand side to December on the right. And on the y-axis, we have the years, and it goes from 1982 to 2024. The colors that you see there relate to the temperature anomalies. So whether is it very much below normal temperatures, or is it above normal temperatures? The blue shows you below normal temperatures, and you can see that from 1982 to 2010, there's a lot of blue there. So these were sort of the normal expected temperatures that you would have. A little bit of brown, but not very much, mostly all blue. But from 2010 on, you see a dramatic change, and there's a lot of brown in there. And the different shades of brown shows you just how much of an anomaly it is, like how much above normal those temperatures are. And where you see those dark lines, those black lines that go across, those are where the marine heat waves are mapped out. And the length of the line shows you the duration of the heat wave, and the darkness of the brown shows you the intensity of the heat wave. So from 2010 onwards, you see that we've had almost suddenly a lot of high temperatures and marine heat waves, and this is in the Gulf of Maine. So let's just deal with some terminology, like we've been using some terms that we're going to need a bit later on. So sea surface temperature, that's just basically temperatures of the oceans near the surface. And that can be measured by satellites or by ground-based instruments. such as buoys or instruments on ships, or you can actually combine all of them to get more accurate measurement and greater coverage. And that's what we actually use in this study. Now, the sea surface temperature anomalies, which is what we were looking at in the previous graph, the anomaly is just how much different is it from what you would expect normally. So normally can be defined as whatever is appropriate. In this case, we defined it as a 30-year average from 1982 to 2011. Okay, so that would be the baseline, and anything above it or below it would be considered an anomaly. That's different. Now, what does that actually look like on a graph? So in this graph, the orange colored line is the 30-year average. It's a nice smooth line because it's an average over a long period of time. The blue line, the more jagged line, is the day-to-day temperature, and it varies. There's higher variability. The anomaly itself is how much it varies, the difference between the baseline temperature, that's the orange line, and the actual temperature on the day that you're measuring. So that would be the temperature anomaly. So what do these anomalies look like over the 5 years that we studied? These are the 5 years that we did, and I've broken it down by season, and on the right-hand side, you can see for the full year. The coolest year of all the years that in this study was 2019. By far, it was the coolest year if you look at the full year average. The warmest year was actually 2022. And it was quite a bit of a difference between 2019 and 2022. 2022 had the warmest winter, spring, summer, and fall. Like right throughout the whole year, it was the warmest. Now, if we had 2021 in here, that would be the warmest year. And what's interesting about 2021, it's not the summer that was the warmest, it was actually the spring that was much warmer. But for the study years, 2022 is our warmest year. And those summer temperatures are much, much higher than normal. Okay, so what is a marine heat wave? A marine heat wave is just a special case of a sea surface temperature anomaly, and when it meets certain criteria. So there's a fancy definition here. We're not going to worry about it. Essentially what it is, it's a strong anomaly that lasts for a while. So if it lasts for a day or two, it's not considered a heat wave. If it lasts for 5 days or more, it could be considered a heat wave depending on how high that anomaly is. And marine heat waves can last for long periods of time. They can last for almost the entire year. Now, as we said, we were looking at data for daily feedings, burrow attendance, and the type of prey that was being brought in. General results that we got from collecting those data. We noticed that the female was bringing in most of the feedings. In fact, she brought in about 2/3 of all the feedings. The male, on the other hand, he accounted for 2/3 of the burrow attendance. He was the one who was mostly there caring for the chick, guarding the chick and the burrow, while the female was out foraging. So that was his primary role, is guarding the chick and the burrow. And if you watch the webcams, you know that you always see Willie in the burrow with the chick through most of the year. For other analyses here, what we did in trying to find out what the associations between sea surface temperature and daily feedings and burrow attendance, we ran some statistical analyses. And what we found from those results is that when the sea surface temperature anomalies were high, the female delivered fewer feedings. So as sea surface temperature increased, the number of feedings she brought in decreased. We found no significant change in the number of male feedings. We also saw that as sea surface temperature anomalies increased, the female had lower burrow attendance. So she was spending more time foraging, so more time fishing, and she was actually bringing in fewer feedings, even though she was spending more time foraging. We found no significant change in the male attendance for what we call it normal years. So in normal situations, there were no significant change in male attendance. Okay, marine heat waves. What are they? Now I know this plot is a little bit, maybe a little bit too small for you to see clearly, but the thing to point out here, these are for the 5 years of the study. So it goes 2017 across to 2018, down to 2019, 2020, and the last one at the bottom is 2022. The thing to look at here is the dark red areas. Okay, those are the heat waves. So you'll remember that we said 2019 was the coolest year that we had of all the study years. If you look at the 2019 graph, you'll see that there are very few of the very dark red areas. So there were very few heat waves. The other thing we can do with heat waves is that we can measure what's called the intensity, like how strong is that anomaly? Is it a strong anomaly? And I've sort of divided up here in different colors from sort of a creamy color goes to the darker orange color. So if those red areas go into the creamy colored area, that's a moderate heat wave. Those are common, not usually something that you worry about. If it goes into sort of the darker tan color, that's a strong heat wave. Those can cause some amount of damage. And in the darker orange, so that's a severe heat wave, which would cause noticeable problems. There's another level which is extreme. Fortunately, we didn't experience any of those in these particular years. So what I'm going to do is actually focus on 2 years. I'm going to focus on 2018, and I'm also going to focus on 2022. So 2018, what I've done here is zoomed into the period when the egg was either being incubated or the chick was already hatched. So the incubation period and the nestling period when the chick is hatched and growing to fledge. At the very top of this, you'll see number 1 with brackets 26. What those numbers mean, it tells you the intensity of the heat wave and how long it lasted. Okay. So 1 is a moderate heat wave. We're not going to worry about those. 2 is a strong heat wave, and 3 is a severe heat wave. And you'll notice that during the nestling period, there was a strong heat wave that built up to a severe heat wave that lasted for 95 days. So it actually went beyond the nestling period to when the chick actually fledged. So that first heat wave that we said was a strong heat wave actually came about when the chick was 10 days old. At the top of this graph, it shows you the chick's age and the intensity of the heat wave. So the very first one, the chick was 10 days old. So still quite young. That built, immediately after that, another one started to build, and that built up to an intensity of 4.1 degrees when the chick was 45 days old. Now keep in mind that chicks would normally fledge by usually around 42 days, 41, 42 days. That would be normal. This chick was there at 45 days when there was this strong heat wave peak. It subsided. You'll see the graph come down a bit, but then it built up again to severe levels just before the chick actually fledged. So that middle peak, that 45 when the chick was 45 days old, that's actually a very significant peak that we're going to spend a bit of time on. Okay, so what was happening to feedings during the time of this heat wave? The feeding graphs is actually the blue bar chart at the bottom there. You see with the yellow arrow points to it. So normal at the beginning, feedings were normal. Even despite that severe heat wave, it dropped a little bit while there was, when the chick was 10 days old, it dropped off a little bit with that strong heat wave. But as this severe heat wave intensified during the main part of the nestling period, feedings dropped off significantly. So there were some days when the chick got nothing. There were some days when she got one feeding. But then, quite interestingly, as that heat wave began to subside, it subsides around August 8th or so, it begins to subside. Feedings increased significantly. So before the heat wave, and that's kind of when things were just getting started and things were more or less normal, she was getting about 5 feedings a day, which is sort of average. Once that peak began to subside at 40, when the chick was 45 days old, feedings increased to over 7 feedings per day, 7.6. And what was happening here is that both parents were feeding. Remember we said that the female normally contributes about 2/3 of the feedings? Well, that was the case at the start of the season. So at the start of the season, the female was making 2/3 of the deliveries as we expected. But as that peak began to subside, the female and male were making almost the same number of deliveries. So the male had significantly increased his rate of delivery. So he was now contributing as much food as the female was. So what was happening with burrow attendance during this time? So that's the dark, it's supposed to be green, graph where the yellow arrow is. So at the beginning, things were normal. Both parents were attending the burrow. Just at the peak of that first heat wave, when the chick was 10 days old, you'll see a drop off in the burrow attendance. But then it sort of built up a little bit again. But during the time of the significant event, as that intensified, the attendance actually fell off. It fell off dramatically. And as it began to subside, attendance fell off even more to almost nothing. I mean, the little blips that you see there were actually time that I gave them for dropping off the fish, but there was very little attendance in the burrow. And that's because both parents were very busy foraging, so there was no time. So they actually spent no time with the chick. They were just busy trying to feed the chick at that point. What was happening with the chick's weight? Now, at 45 days, remember we said that the chicks would normally fledge at around 40, 41, 42 days. And they would normally be expected to weigh around 300 grams. At 45 days, this chick weighed 150 grams. But as the heat wave subsided and feedings began to rebound, you can see that her weight began to increase. Her weight is actually those little purple diamonds in the lower right-hand side of the graph where the yellow arrow points. And her weight actually began to increase quite a bit, quite dramatically, quite fast, as her feedings increased. Now, at 65 days, she was weighed, and the weight was at 349 grams. That might be a little deceptive because she had about 12 or 13 feedings just before that weighing. So she would have been full of fish. So some of the weight is probably actually fish weight, but never mind. Nonetheless, she had put on quite a bit of weight by that time. And she fled shortly after that peak, that severe peak in the heat wave. She fled at 69 days, which is a long, long nestling period. So why is this important? Why is it important that the male was delivering as much as the female in that period? Well, some studies show that the male will actually leave the chick, abandon the chick, or leave the chick for the female to deal with it, and just to look after himself. Willie, in fact, did the opposite thing. He redoubled his effort, and he really put in the work, making as many deliveries as the female did. Now, why is this? We don't know exactly, but it could be that the opportunity presented itself with a good run of hake. A lot of hake was coming in at that time, a lot of good size hake, as you can see in the picture. So it could be that the opportunity presented itself. The food was more easily available. He saw this as an opportunity to boost the chicks' chances of survival because things were quite dire there for a while. And what he did, he traded his guardian role for food provisioning because that was a more important thing at the time. So this is not something that we've seen previously documented, where the male will lend his support to the female in feeding the chick when circumstances are dire. So this was one of the new aspects of this study. So the chick fledged after 69 days. That's actually 28 days longer than would be expected, longer than what's normal. And in this, both parents actually deferred their migration by 4 weeks to sustain the chick to fledge. I must say that this was the last year that we saw that Billy actually had chicks in the burrow. She did return, but she returned late. And by the time she returned, Willie had already taken another mate. She was over the burrow. She was hanging out there for a couple of days. And we think what may have happened is that because of the stresses of the deferred migration and the previous year, she returned late as a result. Good news, the chick, Grace we called her, she was resighted on Seal Island in 2022, and there she is sitting down looking very healthy and very content to be hanging out with the other puffins there. Okay. Now, is this a one-off? Did it ever happen again? Does it happen at different times? Well, for 2022, we have indications that the male did increase his feedings during a marine heat wave. It was noticeable, but statistically, it was not significant. But there are indications there that he did increase feedings during the heat wave. One other instance I'd like to mention here happened this year. So there were times when Millie was away for a long time. I guess she traveled far away. And there was one particular day when she was away for about 11 hours. So from the time she left in the morning and she returned sort of late afternoon. And in that time, Willie was in the bar with the chick, and he made 5 deliveries. He went out and he got 5 feedings for the chick during that time. Millie eventually made 2 on that day, I believe. But again, another circumstance where the chick would have gone hungry had he just waited for Millie to come in. So he went out and he got a few deliveries to keep the chick um, sustained and not hungry for that period of time. So I think we need more studies to find out just exactly what is happening here. But there are definitely indications that in other circumstances or in other situations, Willie or the male will actually go out and supplement female feedings if needed. Okay, let's turn our attention a little bit to the types of prey that was coming in. Now, normally, puffling chicks, they're tiny, they're small. They swallow their food. They do not pick it apart like the way raptors do, for example. They actually swallow their fish whole. And so they like to have small, slender fish that they can swallow easily. Things like sandlands, even herring, if it's not that slender, but they can swallow it. Hake, they can swallow those small fish as well. Now, the butterfish, the American butterfish, is not a small, slender fish, even if it's small. It's what's called a deep-bodied fish. So you can see it has a deep body, or if you look at in the picture how wide it is, the width is about a third the length of the fish. Sometimes it looks even bigger than that. So it's very wide and it's hard for a chick to swallow. It's too wide for small chicks to swallow. However, the butterfish, it's a high lipid fish. It's calorie dense, and it's potentially a good meal if the chick can swallow it. But in most cases, the chick cannot swallow it. And so if there are a lot of butterfish being brought into the burrow to feed the chick, that chick might suffer some consequences from that. They might have lower weight, lower growth rates. And in worst case situations, they might actually not survive if all that's happening is that they're being brought these fish that they cannot swallow. So they're certainly not ideal, though if the chick can swallow it, it's a good enough meal. So looking at our 2018 chick, Grace, the two green dots there, if you can see them, that just marks where the hatch and the fledge points are, if you can remember those. So at the beginning of her nestling period, there were very few butterfish being brought in. Okay. Once the heat wave got to its high peak when she was like 45 days old, then the number of butterfish that was being brought into the burrow increased significantly. By that time, she was a little bit older, and she could actually swallow many of them. But when the feedings rebounded at this time, a lot of hake was also coming in. So she was able to swallow quite a few of those butterfish. But she was also sustained by the hake that was coming in as well. Okay, so we're going to talk about the 2022 chick and the heat wave of 2022. The chick in 2022, we called her Florence. If you look at this graph, you'll see that her incubation period is in the sort of cream-colored part. So most of those were moderate heat waves. However, her nestling period was the entire nestling period was a long duration heat wave. And it's the strongest heat wave that I've measured for the study years here. And that built and intensified over the entire nestling period, and it intensified to severe levels. So you see it sort of peaks up in that dark orange area. So she was 43 days old when that peak occurred. So I've combined the feedings and the attendance in this graph. So the blue, that's still the feedings. Her feedings were kind of more or less steady throughout, but the quality was not always good. She did get some really good feedings. She got some, especially around the time when the heat wave peaked. She was getting feedings that had maybe one tiny little fish. Sometimes it was just like an egg sac, like you could see the sac with the fish developing inside. So the things weren't that good at that point when the heat wave peaked in the last few days of her time there. And she actually fledged at 46 days, so just after the peak of that heat wave. Now, what was she getting to eat? Okay, so on the right-hand side, we see some graphs. The top graph shows you what she was getting to eat. The top one is butterfish. And you can see butterfish, she got right throughout the entire time that she was in the burrow. There were more during the time of the heat wave, but she did get like right throughout the entire nestling period. The good thing is that she also got other kinds of fish. She got the Atlantic saury, so that's the middle graph, and most of those came in the early part of her nestling period. They are large fish. They're long, but they're slender, and so with some effort, the chick can actually swallow it. It's a pretty good meal because it's fairly high lipid. And because they're so long, one of those would be equivalent to maybe 2 or 3 normal feedings. So the Atlantic saury there, again, that's a warm water species. Not usually found in the Gulf, but she got a few of those, and those kept her going. She also got sand lance. That's the bottom graph. So the bottom blue graph, sand lance is perfect for her. You can see that it actually fell off. The number of delivers of sand lance actually fell off as the heat wave peaked, as did the number of sauries as well. And at that point, once the heat wave intensified, she was just getting mostly butterfish. Now, if you've ever seen a chick trying to eat a butterfish, it's not a happy sight. It takes a lot of effort. It's a lot of struggle. It takes a lot of energy. And it's not nice to watch. I mean, it's a struggle for them. It really is. And you can see how big some of them are for the tiny chick. But Flo in 2022 had other ideas. She decided this just wasn't going to work for her. So this is what she did. She figured out how to pick this butterfish apart. If you've looked at the paper, you've probably seen this. This is one of the appendices. By this time, she's got the fish down to half its normal size, and she's just pulling it apart. From time to time, she would try to swallow it, but she'd go right back to ripping it down until it was a small size that she could swallow. What I'm going to show you in the next slide, it's actually the same fish, but when it was brought in at the beginning. And notice in this one how she goes for the gill cover. She figured out by this point that was the weak point on the fish. So she would always go for the gill cover and begin to pull stuff out out there and then begin to whittle away at the fish. So let's have a look at that. I hope you can see. So here's a fish Millie brought in. See, she goes for the gill cover right away. And then she sort of hacks at it and hacks at it. And then she begins, if she finds a weak spot, she'll begin to pull out the guts and anything that's soft that she can pull out of it. And then she keeps at it. Notice in this one now, she keeps going for the gill cover. She keeps ripping away at it. And in so doing, she can get all the parts underneath, but she can also get the head off. And that's her strategy for getting the head off. And then she continues whittling away at it until, like in the previous slide, you saw she got it down to half. And sometime after that, she got it to the point where she could swallow it. Now, it does take a long time. I think she spent about an hour with this fish. She takes breaks in between, so she might stop, have a nap. Maybe she gets another meal, she'll have that, and then she'll come back to it. So it's certainly not ideal, but this is what she was basically feeding on at that time. Like she was just getting a lot of butterfish coming in. And so by being able to actually find a way to eat the fish and to get the benefits of this high density fish, that certainly helped her along and helped her to grow and to develop. Flo was actually another good news story. Flo was actually resighted on Seal Island in 2024. She was 2 years old at that time. And she's come back every year since. She was seen in 2025 and in 2026 as well. So it's always nice to see when they return, and particularly when they've had sort of a difficult time growing up. So as they mature in the burrow, if things are a little bit difficult, it's nice to see them return looking strong and healthy. Now, have there been other instances of this? So in 2024, I have clips. Well, not clips, but that the chick in 2024 was actually Amma, and she had 2 instances. She didn't get a lot of butterfish, but she got some. There were 2 instances where she actually picked away at it. Wasn't quite as dramatic as Flo was, but she actually picked away at it until it got a bit smaller and she could eventually swallow it. But like I say, it wasn't nearly as dramatic as Flo's experience with them. The chicken 2026 had a lot of butterfish. She just got streams of butterfish coming in the burrow almost right from the start. She did some amount of picking at it, but she actually swallowed most of them. She was able to swallow eventually. So it took her a long time. She might start. Sometimes she got one and she'd just look at it and leave it and then come back to it later. But she actually got back to them, like, later in the day, and she was able to swallow most of them. The one instance where she did there was significant picking apart of a fish. She got this large fish. I think it was a haddock. You can see in picture 1, Millie brought this large fish in. The head area was a little compromised because of the way Millie was holding it. So it was a little compromised to begin with. And the chick sort of hacked away at it until she was able to pull off the head, which you see in the second picture. Now, in the third one, she's gone further, and she has actually cut through about a third of the remainder of the body of the fish. You can see it's in 2 pieces there. She actually by pulling apart that middle section, she was able to cut it into two pieces, and she continued to hack away at it until in picture 4, you can see she got a good chunk of it. That's the last little bit after she'd been hacking away at it for a while. That's the last little bit, and she swallowed that part. And then she went to sleep for a long time. And she came back later, and that's in picture 5. And she found the tail part that was left, and she swallowed that tail bit. So in this instance, she did a lot of pulling apart or tearing up this fish into small bits and pieces so that she could swallow the bits and pieces as well. So Flo was certainly the most dramatic, and she did this with a butterfish. But here we also see with a different kind of fish, which is probably easier to pull apart. But our chick this year, Tilly, also showed that she's quite capable of tearing apart a fish as well. And she was 19 days old at this point. Okay. So just to finish up here, what did we draw from all of this? We know that the Gulf of Maine has been warming. Puffins continue to breed in the colonies in the Gulf of Maine. They have been breeding a little bit earlier, perhaps to adjust to the changing temperatures. So what we see in the study, we see parents and chicks adjusting to the changing food conditions due to the climate change, due to the warming of the Gulf of Maine. We see the parents adjusting their traditional roles. So we saw Willie, the male, trading his chick guarding time, for provisioning the chick so that the chick could survive and fledge. We saw the parents deferring migration for 28 days. That's a long time for them to defer the migration, but it's the opportunity was there to sustain the chick to fledge, and so they did that. And quite dramatically, we saw the chick, this particular chick, learning how to eat the butterfish, which she just was fed up and wasn't going to try to swallow it. She learned to eat it in pieces. So piecemeal when it couldn't be swallowed because it's just too much. So that's basically that for the study. I certainly would like to thank so many people, Explore.org for installing and maintaining the cameras, for having them available to us 24 hours. So Explore and their technicians and all the people who keep those cameras going. Project Puffin, Seabird Institute. All of this would not be possible without them. So thanks to them so much for all that support. And to my co-authors on this paper, Dr. Steve Crash, you all know him. You know him, you love him. He's the founder of Project Puffin and so many accolades as well. Don Lyons, who is the director of the Seabird Institute, also affiliated with Oregon State University. Keenan Yakola, who we knew for a very long time as the supervisor at the Seal Island colony for Project Puffin. So he is now affiliated with Oregon State University as well. So thank you to all of you. And of course, thanks to all the viewers who are just great people, past and present. Super great people. So happy to be a part of the group. So thank you all very much. These are just the sources if you want to have a look at them. And then if you have any questions, I'd be happy to take them.
Amazing. Thank you so much, Julie. That was so interesting. We do have questions coming in the chat, and I think you just answered one of them. Is there anywhere that viewers can read more about this? So if you want to pause on the last slide a little bit so some people can take down that information.
Okay,
Perfect.
I'll come back.
Awesome. And I also had a couple questions come up during that, if you wouldn't mind answering my questions.
Mm-hmm.
So, do you know what made 2019 the coolest year on record, or that you were studying?
No. 2019 was probably closer to normal. And since then, we've had, I think it was 2024, that was also closer to normal. So there have been fluctuations. The I think the big question is, why did it suddenly change in 2010? Like, why was there almost a dramatic change, as you could see in the sea surface temperatures, temperature anomalies there. And one of the reasons that's been given for that is that there was an influx of warm water from the Gulf Stream. So the Gulf Stream passes further off the coast, but it passes by the Gulf of Maine, and it's believed that there was a strong influx, or has been a strong influx of um, very warm waters from the Gulf Stream coming up. Why 2019 was cooler than normal, I actually don't know the particular reason for that.
Okay. Well, thank you so much. That is really, yeah, interesting. I had heard about the Gulf Stream contributing to why the Gulf of Maine is warming.
Yeah.
But yeah, definitely interesting and frightening to think about. Another question of mine is, what are the consequences of parents spending less time with the chick? You'd said in years when there was less food availability, the male would stop doing the guardian behavior as much and
Yeah.
start
Yeah.
participating in feeding more. What are the
Mm-hmm.
consequences of kind of that breakdown in roles?
Okay. So what happened? I can tell you what happened to Grace in 2018. It just means she spent a lot of time alone. In that particular case, she was hungry, and she was alone. And unfortunately, there were a few prospectors coming in. And so it was sort of heartbreaking to watch because she was underweight, she was undernourished, and prospectors would come in and they would attack her. And so that's one of the consequences of not having a parent there to keep watch. No, that's not always the case. Um, Actually, this year, Tilly did spend a fair amount of time alone on some days. Um, but quite often, what happens is when parents are busy feeding, prospectors are also busy feeding. So they don't necessarily have time to be hanging out in the colonies. But in cases where they do find the time to go out into the colonies, the chicks have a really hard time, and it's certainly not ideal. Obviously, she survived those attacks. None of them were. Well, some of them we thought were severe. There were ones that I couldn't watch, um, and but some of them were actually quite mild. Or in some cases, the prospector actually sat with the chick and preened the chick for a while.
Mm,
Um, yeah, so them being alone, it's certainly not ideal, but I guess it's a balance of weighing what needs to be done. Feeding the chick was the most important thing at that point, if the chick was going to have a chance to survive.
that makes sense. Okay, one last question. I want to be respectful of your time here, and thank you so much again. That was so interesting. Do you think other species might take advantage of the male's reduced guarding time due to increased feeding to prey on the chicks? Um, so the viewer that asked this question said that they're not familiar with other natural predators yet. So just maybe a
Yeah.
refresher on that sort of dynamic.
So gulls are natural predators, and there's certainly lots of gulls on sea land. The nice thing with the bars is because they're so intricately underground, it's hard for gulls to get underneath into the burrows. If the chick comes out, then of course it's exposed to high risk. But gulls themselves cannot get into the bars, I guess, unless they're like there's an open bar that they get into. Um, and I don't think there are other animal predators on Seal Island, so they're safe in that regard. So generally, I think they're safe as long as they're underneath inside the bars.
That makes sense. Yeah, the puffin burrow is a marvel of engineering for anybody. I've been on Seal Island,
Yeah.
and being any sort of large mammal, trying to look inside of them even to see if there's an egg or not, it's very
Yeah,
difficult.
you'd have to be very sinuous and snake-like to get in there.
Yes, yeah. Well, thank you so much again. So interesting. And yeah, I really appreciate the amazing work that you're doing. And yeah, the ability to kind of have synthesized all of this information that was available on Explore into this study that's really interesting on how, the chicks and the parents are adapting to the changing temperatures in the Gulf of Maine. I mean, it's worrisome, but there's also so much hope in there as well, both with the parents adapting and also being able to see the chicks kind of adapting their behavior. So really cool
That's right.
to witness.
Yeah,
Yeah.
yeah. Well, thank you so much. I really appreciate the offer to be here. I'm very grateful and honored to be able to do this. So thank you.
Yeah, thank you again. Have a good one.
Thanks. You too.